show of hands. Okay, so some of us. All right, the good thing is you probably won't need too much from the first, actually you won't need the first meeting knowledge to understand what's going on here. I just thought it was a really good background to have. Hopefully you guys maybe got the slides from last time or something like that. So quickly, let's go over agenda. Today there's going to be 3 of us speaking. It's going to be Eugene first, then Eileen, then me. Eugene is going to talk about just getting yourself set up with Metamask. So Metamask is a crypto wallet. Have you guys heard of a crypto? Have you heard that term before? Crypto wallet. Okay. So a wallet is just pretty much it's going to allow you to actually like store funds, interact with the blockchain, things like that. So you need to actually create that first before you can do anything at all blockchain related. So Eugene is going to help you get it set up with like probably the biggest wallet provider called Metamask. So really good thing. Listen in, and hopefully, does everyone have a laptop? You will need a laptop for this. Okay. I don't see any nods, so I don't see any shake heads, so we should be good. Cool, so he will get you set up with Metamask, and that will be necessary for the later part, so if you have any trouble, just feel free, raise a hand. One of us will come help you. Then Eileen is going to give you some Ethereum fundamentals, just a little bit more, won't be too much. But she is going to help you interact with your very first smart contract. So a smart contract, and I'll get into a little bit of this more later, but a smart contract is pretty much just like code. So you can call a smart contract that we've written to get yourself some of our own. We created an ERC20 token, which is, for all intents and purposes, just think of it as, it's not really money, but it's kind of money. It won't get you anything, but it's just like nice to be able to understand how to interact with these things. So she will set you up with that, and then I will help you deploy your very first smart contract, and we'll do some actual programming in Solidity. I'll get you set up in an IDE, and we'll actually deploy a real smart contract to the blockchain and look over some stuff. So sound good? Perfect, should be productive. So Eugene, want to kick it off?
Cool. All right, grab your laptops. All right, so as AJ already said, we need to set up a wallet to actually interact with the blockchain. And the wallet that we're going to use today, or we're going to set up today, is the Metamask wallet. So go search up metamask.io on your computers. Make sure you're on Google Chrome or Firefox if you're using Safari or any other browser. Unfortunately, Metamask is not supported for that. Also, if you don't have a laptop, just follow along. It's fairly simple. So once you get to that site, click download, go to the respective place, and then just download the extension. Make sure you're downloading the right extension, because if you download the wrong extension, you might get a virus, and then they might just steal your funds. So make sure it's like Metamask, and then there's a lot of users on the extension that you're downloading from. Yes. Oh, and we're also going to install this on the laptop instead of a mobile app because it'll be much easier for development later on, especially because you want to have your account address, which is that huge hex code or hex string, and most people's not going to remember that, but you can copy paste it from the Metamask extension. Has everyone downloaded this? Nods? Hand raise? Cool. Yell at me to slow down if you have not. So now you're going to get to this site, or this page. Does everyone see this? Cool. We'll get started. We're going to go and click the right button, create a wallet. So if you already have a wallet, you can just import the secret recovery phase or phrase, and then that will import your original wallet into this Metamask extension. But for all intents and purposes, we're going to create a new wallet. So click create a wallet on the right-hand side. Now, set up your password or create a password. Use something secure. I'll give you guys like 15 seconds. Cool. All right, after you set up a password, you're going to get to this page. Now, when you click here to reveal secret words, it's going to give you 12 words. Keep these 12 words super secret and store it safely, because if anyone gets these 12 words, they have access to all your funds and they can take your funds. But, just don't show people these 12 words. So these words are important because if you ever want to migrate to another computer or transfer your funds to another wallet, you're going to use these 12 words, you enter it, and then all your funds will appear on this new wallet. Or if you ever reinstall Metamask, you'll use these 12 words. So get those 12 words, store them down somewhere right now. For now, you can put it in notes or somewhere, but The safest place to put these 12 words is somewhere that's not connected to the internet, because if a hacker ever gets access to your computer, they can find these 12 words and they'll take all of your, or they have access to all of your funds. But if it's on like a piece of paper or some hardware wallet and no one can actually access that other than you should be fine. So after storing those 12 words, you'll get to this page and just put in the 12 words that you're given. I'll give you guys some time for this. Once again, I want to reiterate, don't ever show your 12 words to anyone. It's actually like one of the most important things in keeping your wallet safe.
I have a quick question.
Yeah.
Does someone need just the 12 words to get into your account, or the 12 words plus the password that we just made?
So they actually just need the 12 words to get into your account, because what they can do is on their own computer, they're going to install Metamask, and on the earlier page, remember there is a box that says import from your other phrase. They just type in that phrase and then they can have access to your account. And this works across other wallets as well. So just make sure you keep those 12 words safe. Because the 12 words are generated based on your actual account address. Cool. Has everyone finished this step? Any questions? All right. So I think that's pretty much it. I get to this page, click all done, and this is basically what you see. This is your brand new crypto wallet on Metamask. I think that's everything. Any questions? Cool.
Everyone get to the screen? We're good to go? Cool.
Keep those 12 words safe.
Cool. So now that everyone has a MetaMask wallet set up, I'm gonna briefly explain like how addresses work, and then we're gonna get some test ether from a Ethereum testnet, and I'll explain what that is, and then we'll go through calling a smart contract that AJ wrote up, and then that will transfer a token that smart contract created onto your wallet. And then as a bit of extra, I'll talk about ENS domains. Okay, so when you first made your MetaMask wallet, at the ending page, there should be, at the top over here, it says like account 1, and then there's like the 0x and then a bunch of characters. So when you click on that, that'll copy paste it to your clipboard, and basically, that's your Ethereum public address. So your public address versus your private seed phrase, the way it works is in the MetaMask extension, I guess. The private seed phrase is stored and you log in through there to actually access your wallet. But then when you're working with your public address, you can send that to other people and say like, if you want to transfer funds to me, send it to this address and then it'll go directly to your wallet. So public addresses always start with a 0x. So in this instance, we made a wallet address. So these are all accounts that basically can hold funds. But other things can also have addresses on the blockchain. So there's smart contracts. When you write a smart contract and then deploy it to the blockchain, it's immutable. So it needs to, when you're calling that smart contract, you need to be able to access the right block of code. So you access that contract by calling what's at a specific location, which is indicated by the smart contract address. In order to see what an address is doing, there's this website called Etherscan. If you want to look at it right now, it's etherscan.io. Basically, it is a website that has a publicly available list of every single transaction coming in and out of an address. So that works for your wallet, contract addresses, DAO addresses if they have like a public wallet. Also, you can see what your address is doing by looking at whatever wallet app you have. They'll always have a transaction history, so you'll see like what's been going on. So next I'll be talking about Rinkeby. Basically, Rinkeby is one of the many Ethereum testnets. And the way I think of testnets is kind of like monopoly money. So a testnet is technically a way for Ethereum developers to deploy their contracts and get a chance to test it in a Ethereum-like environment, I guess, without actually putting real funds or real money at risk. Yeah. So RINC-V uses proof of authority, and there's also different types of testnets, or there's different testnets available. So Kintsugi is using the merge, which is coming soon to Ethereum, which is very exciting. There's also Ropsten, Koban, and Goerli. And also, if eventually, hopefully, we'll be able to start developing Ethereum code in our own local environments. So if you start a local testnet, that'll be localhost 8545. Does anyone have questions about testnets? Okay. So how do we get money from a testnet? Just a reminder, this is still like monopoly money. So even though it says in your wallet, oh, you have 4.5 RINC-V Ether, you don't actually have like $15,000. It's just like fake tokens on a fake network, if that makes sense. So basically how people will work with it is that there are faucets that drip funds. So you can input your Ethereum address, and your Ethereum address stays the same through different testnets and also the mainnet. So the wallet that you made right now will work for every single testnet, but you'll have to make sure that you're on the correct network. So you input your address, you request a certain amount of funds, and then you wait a little bit for the transaction to be confirmed. Then it gets sent to your wallet, and then you have monopoly money. Where this money comes from is from testnet whales, so they like donate monopoly Ethereum into a faucet. Yes, and there's also different faucets for each testnet. Okay, so how to actually get monopoly money? Visit this link on the screen. Yeah, and then click on the little Metamask icon, and then click that area to copy it to your clipboard. Oh yeah, copy your wallet. Is everyone on this page? Moving on. Okay, so this is a screenshot that I got before, but hopefully it still looks the same. There should be a place for you to write like testnet account address, and then make sure that Ethereum RINC-V is selected, and then just paste in your address, and then request 0.1 test ETH, do the CAPTCHA, and then send request. And then once you do that, there'll be a page where it like loads your transaction. So that'll take like a minute or so. Yeah. Here's the slide. You just paste it in and request. Okay. So I guess while that is happening, I'm going to show you guys how to switch your network. So open up the Metamask extension thing again, and then along the top, there's like a drop down. It's like you click on this thing, and then there's a drop down of all the testnets available to you, and click RINC-V, and then once you click that, then your Ethereum wallet should look like this screenshot. I'm gonna assume that it's okay. If anyone's stuck, feel free to ask the people in the back. AJ and
Like $170.
Are you just can you just step there where you track the testing? Yeah, so the faucets. Okay, great. Here we're good.
Oh. Wait, does anyone only see Ethereum mainnet?
yeah.
Okay, you guys are gonna need to go to hold on one second. At the very top, right above Ethereum mainnet, it should say show/hide test networks.
Yeah.
Go ahead and click the show/hide, and then toggle show test networks to on. And then you'll be able to see all the test networks. Thank you. And then, yeah, go to Rinkeby. And then, if you go to Rinkeby, you should see.
Yeah, but there is.
Okay, so let me say, go back. Oops, so we're gonna move from Ethereum to.
My stomach's kind of just full right now. So.
I have not seen this before.
They just go to the settings like manually set and then
Let's see.
like
Here, 5. Here's like
One problem.
maybe it's an account system. It's an advanced, yeah.
Does anyone not have the show/hide test networks? Or is everyone able to see the Rinkeby test network? That's toggle to it. Yeah, everyone sees 0.1 ether.
Okay, cool. So hopefully, if you're stuck, make sure to ask AJ or someone in the back for help, but I will continue explaining. So first off, there's this thing called ENS names. So you've probably heard of DNS. It's domain name system, which is like the phone book of the internet. That's how you can type in a domain name and enter a specific website. So ENS stands for Ethereum Name System, and it's like the phone book of the metaverse. It's basically this open source software that registers ENS names and makes sure that like each registering controlling person has control over their ENS name for a certain period of time, kind of like how you can register a domain name for 1 year, 2 years, 5 years. So the reason why ENS names are useful is because, let's say I have my ENS name registered as eileenz.eth. Instead of telling people, hey, can you send funds to 0xEAF, blah, 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 I can tell people, hey, send funds to eileenz.eth. So this helps basically with like Web3 identity for most part, and also for making Web3 more readable. So both are functionally the same, and you can even search up ENS names in Etherscan. So if you like typed in eileenz.eth and like clicked around, you'd be able to see my wallet's transactions. And most importantly, you can also get ENS names for contract addresses, and that's helpful because it can help prevent with scams and stuff, because people will say, oh, this is my project's contract address, but if it's not actually the contract address, then you may be sending your funds to the wrong source and you could have your funds drained from your wallet. So always make sure that you're interacting with the right contract. Okay, so what we're gonna do is we're gonna send Rinkeby Ether to a contract that AJ wrote. After sending that amount of Ether, it will send back this token called UpAvery. Yeah. So we're gonna send the funds, import the token, and then see the token in our wallet. So cool. So in Metamask, there should be a button that says send, and then an arrow. And make sure you're still on Rinkeby. And then when it says like where to send it to, type in Blocktech Spring 2022 reward1.eth. Basically step 3 in this list, and then click around until that screen shows up, and then click next. And then on the right side, make sure to put in 0.005 ETH, and then click confirm. And then through that, you'll get a page that says like, confirm this transaction, sending 0.005 ETH to this address. It will cost blank amount of gas. So we'll cover gas another time, but basically it's like a transaction fee. And then once you go through that, it'll be pending for about a minute or so. Okay, so So the second thing we're gonna have to do to see the tokens is register it in our Metamask wallets. So this stuff is necessary because it's like a custom token we deployed, so Metamask isn't gonna automatically detect it. So what you're gonna do, I made this paste bin link. If you type that in, it should lead you to a thing with a contract address. Yeah, so copy paste the text. And then what you wanna do from there, in Metamask, click on assets and then import tokens. So they're like circled in red. And then paste in the contract address. And then the other stuff should auto-populate, and then press next or press add custom token. And it should work very normally.
I'm sorry, so once we get to this site, you just want us to copy the paste data that's in the.
Yeah.
Okay.
Damn, you need to win now. My friends do this. It's really funny.
Oh, you're saying.
I can't believe this is a flaw. It's so true. It's so much better than that.
This is my kind of bio.
Yeah, so once you've finished importing tokens and pressing import tokens, you should be able to see this right side screenshot where you have your ring-free ether, and then you also have your 5 update-free tokens. And yeah. Oh, also if you want to look at this transaction on Etherscan, since we're on Rinkeby, you'll have to go to rinkeby.etherscan.io, but then once you paste in your wallet address, so go back to Metamask and copy paste it from that top box, paste it into Etherscan, and then you should be able to see like the first transaction at the very bottom is the faucet transaction, and the second one is when you sent funds to the contract, and then you get 5 of Avery if you like click on this drop-down box with tokens. So you have tokens, everything's public, yay blockchains. Yeah. And that is it for my part.
That's it. Oh, you don't have it? Yeah. Might not be long enough.
Okay, so
Yeah.
is everybody done with the first phase of stuff? Ready to move on? Cool, so we have maybe about 30 minutes left. I'm just gonna get through as much of this as possible. If we don't finish it, not a big deal. There's gonna be a couple slides just to give you some like overview, like what do the types look like, what do the variables look like in this language called Solidity. And then most of it's just gonna be a live code demo where we deploy stuff. So we'll just see how far we get. Cool, everyone ready? Perfect. So before we get into the nitty gritty of what is Solidity, I wanna give you guys a high level overview of how Solidity interacts with the blockchain. So last time, if we remember, we talked about blockchain as just like this decentralized ledger, right? Like it just has a bunch of transaction information, right? So the question is like, how do you actually write code on top of something that's just supposed to track transactions? And the answer is you can kind of generalize this idea of a transaction to data, right? Like really the system we designed helps us figure out how to decentrally keep track of data, right? And so code is data. So the great thing is I can write code and a bunch of different nodes, right? Remember a whole network of a bunch of different people cooperating with each other. They can keep track of what data and what code exists. So when I write a Solidity file, right? So just like a Java file or a C file, it ends in .sol. So that's your initial Solidity file, and you write that source code. So we'll go over exactly how to write that. But once you do that, that gets passed to a Solidity compiler. So Solidity is a high-level language, so it gets compiled, and once it gets compiled, 2 things are spit out. One is ABI, which stands for, I think it's like Abstract Binary Interface, or I may have gotten that wrong. But ABI is pretty much just like JSON data of how people know how to interact with the contract you have just written. So we'll take a look at ABI later, I think, if we have time. And then there's byte code. And byte code looks a lot like assembly. It's just byte code then gets further moved into opcode, and that literally runs on an Ethereum virtual machine. And that opcode or byte code is what is on the blockchain, publicly available. So if you go to the blockchain, you look at a smart contract, you can actually see the byte code and the opcode. But you won't see the source code necessarily. Make sense? So that's how the general flow works. Great, so let's look over some basic syntax rules. We have one more slide and then we'll hop into code. So the general introduction to Solidity, it is a high-level, statically typed smart contract programming language. So there's three things to break down there. One is what, oh, can you guys see? Okay, so the first question is what is high level? So high level means doesn't look like assembly or machine code. It's like Java, C++, Python. These are all high level languages. So it's like easy to write, makes a lot of intuitive sense. In my mind, high level means easy, so that's nice. Statically typed means we actually have to say what types there are. So in Python, a lot of the time, I think CS1 is still in Python, right? So you don't need to actually explicitly say what types you're using. But in Solidity, it is statically typed, so we will have to explicitly state this is the type we're using. And the third part of that is smart contract. So a smart contract is this bit of code that I've been talking about, that you can actually write, store on the blockchain. When we do dev work, everything we write is a contract. So we call it a smart contract. I guess general other things are we use curly braces to delimit sections of code, which we'll see, double slash for a single line, that thing for a multi-line comment, which I'm sure we've all seen before. There's really super standard stuff. Like it doesn't feel that much differently, and I'm sure once we start coding, you guys will see that. If, else, while, for, etc. There's a couple new things which we'll go over today called modifiers and the require statement. The require statement is pretty much an assert, and it forms the backbone of a lot of how we make sure the right people are calling the right functions. So require is really useful, and then modifiers we'll get into soon. Cool, so variable types. At a high level, there are two variable types. The first is state variables, the second are local variables. So state variables are declared at the beginning of a contract. Is everyone familiar with classes? So the easiest way to think about contracts is it looks like a class, it pretty much is a class. So it's literally, you would describe it as like contract and then insert name here, open curly brace, close curly brace, and then everything inside here looks exactly like a class would. You have state level variables or class variables, and then you have functions, and inside these functions we have local variables. Now, important things to know. So this programming language, like when we actually release or deploy a contract onto the blockchain, if you think about it, anytime I write a state variable, that is going to be permanently stored in contract storage on the blockchain, which means it costs money, right? So luckily, we're not using the mainnet, we're using a testnet. So all the things we deploy, we will either use a testnet or just your local blockchain, so you don't need to pay any money to deploy your contracts. But if you wanted to actually deploy a contract and like do work on the mainnet, which is, it's just equivalent to doing stuff on a testnet, like nothing changes except where you're deploying it, so you will be getting the full coding experience. It's just that if you were to do on the mainnet, you would actually have to pay money, which we don't want to have to do. But yeah, so it costs this thing called gas, which we'll probably talk about next time. Other important things, state variables, once you initialize them, outside of the constructor or a function, you can't change its value, so that's a little bit of weird functionality, but it's just how it works. And then local variables declared inside functions, and we'll get into that last bullet point more about this keyword memory. We'll see that today. Cool, so this is an example of some like basic Solidity code. Very, very simple contract. So at the top, we see this thing called SPDX license identifier :GPL-3.0. That is in a comment, but if you don't have that, you will get a compiler error or a warning. I think it's a warning, not necessarily an error. But you need that in case your source code is ever public. You need to explicitly state what your license is. GPL is the general public license. I would just stick with that. The next line is Pragma Solidity, and then we have this number. So the Pragma keyword tells like your file what version of Solidity you need to compile. So remember I said that the source code gets passed into a Solidity compiler, right? Well, there's different versions of Solidity constantly getting updated, so there's certain bug fixes and things that happen, and so we need to identify exactly what version we're going to use. In this case, I actually don't like writing it like this because it can literally only use 0.8.7, which in my opinion is not great. So when we do the live coding demo, which is right after this slide, I will show you a better way to sort of handle Solidity versions in that Pragma statement. Okay, now we get into the contract. So lines 5 to 19, that's just the bulk of the contract. As we see, it looks exactly like, does everyone see how this looks like a class? This looks really similar, right? We have the word contract instead of class. We have the name of the contract, open curly brace, close curly brace, uint public value. So what that's doing is that's creating a state level variable of type uint. Uint is unsigned integer, so integers can go negative, uints cannot. Public is its visibility, and then value is its name. Does that look fairly intuitive, that first line? Usually we would do like public int value, right? Like that might look more familiar. In Solidity's case, we do type first, then visibility, then name of variable. Okay, the next thing is we have this constructor. So the constructor is the function that is going to get called when you actually deploy the contract. So in this case, we're initializing the value to 0. This is not a big deal because we actually don't need to initialize the value to 0, just semantics. Different types have their own default values. So let's say I just completely deleted the constructor. The value would be 0 already, just because the default type of a uint, or the default value of a uint, if you don't assign anything to it, is 0. Then we have two functions. Has everyone just seen like setters and getters before? We're just setting the value and getting the value. So just to break this down, just because it's a little bit syntactically heavy at first, let's look at the set function. So every function starts with the word function, then you have the name, and then within parentheses, you have whatever arguments you have plus their types. Then you have the visibility at the end. And then braces, and then you have your function body. So does set value make sense to everybody? Looks intuitive? Cool. Then we look at get value. So get value's first line looks a little bit longer, and so we'll break down each thing. So again, we have function, that's just like the keyword we need. Then we have get value, which is the function name, nothing inside the parentheses because we're not passing anything into it. We have the visibility, public, and then we have this thing called view. So view has to deal, or I guess, anytime you write a function, you need to assign it one of three values, either nothing, view, or pure. And so with this, most of them are probably going to be nothing. As we can see, set value has nothing. There's no view or pure in it. But the reason we do this is because if your function interacts and changes the blockchain, so if you actually like change a value, for example, set value is changing value, right, which is a state variable, so we're actually changing the blockchain. If we do that, then we don't include anything. If we are just looking at the blockchain, so get value is not changing anything on the blockchain, we're just looking at it, we use view. And let's say I were to write another function that's just like min, like I just want a helper function that doesn't look at the blockchain, doesn't alter the blockchain, then I would use pure. Does that make sense to everyone? Cool. So I think with that, I can probably just get into a live code demo of stuff. So let's have everyone go to remix.ethereum.org. And I will try to make this sufficiently large so we can see it. Maybe a bit larger. Okay, that's too large. Okay. Remix, oh, actually, I probably should have put that up. Does everyone have it? Remix.ethereum.org. Let me see if I can go back. It's just this thing first. This thing right here. All right, I will assume everybody is here. Perfect, so let's do a quick tour, I guess, of the interface, and then we'll get to coding. So on this side here, we see this is our like left space, I guess, sidebar, I guess I'll call it. It just has all our files that we're working with. Don't worry about workspace, we'll just look at these files. Contracts is where all your contracts are stored. If you clear your browser cache, this stuff will disappear. So that is why usually when we do Solidity development, we aren't going to do it on the browser with Remix. We'll actually use VS Code, we'll set it up properly, but this is good for teaching purposes. So you can see, like, since I last cleared my browser cache, this is all the stuff that I want. Cool, so then let's move here. So this little sidebar here, these are the only three things. This guy shows our files. This right here will let us choose our compiler version. We're just gonna stick with the most recent one for today, but you can see you can go all the way back to like, oh my goodness, 0.1.1. So that's how you choose that, but we'll stick with this. Language, make sure it's on Solidity. We'll do compiler default. Now, I think autocompile probably will not be checked on most of your computers. Go ahead and check it. It's going to make our life a lot easier. It just helps because you'll get automatic feedback when you're writing code. Usually what I do is, like, not all the time when I write code, it's not always like perfect or going to pass compile checks, so it's just good to have that instant feedback. I just be like, oh, I forgot this here. Cool. Yeah, we can manually compile, but we won't do that. And then this will come soon. Once we actually compile a contract, then we'll be able to see that. And then down here, this is how we actually deploy. So Remix is an IDE, and it's so useful because it has this very easy way to just deploy your contracts. You don't need to do anything funky in the terminal. Like, there's no weird stuff. It's very simple. So there's 4 different things that we can deploy on, or 4 different environments. So the JavaScript Vms, these are just, you can think about them as sandbox blockchains. Like, they just start up, no one's using them, they're local to you. Obviously, you don't need to worry about like security on this sort of stuff, right? Because you don't really care, it's just a sandbox blockchain, so there's no virtual network running. It just simulates the idea of putting blocks after blocks after blocks. And this is how we're going to do the majority of our deployments today. It's just on your own local blockchain. But we will do injected Web3 once, just so you guys can say you've deployed something on at least a test net. And if you do injected Web3 and you try to deploy something, you'll see that it actually connects to your Metamask wallet. So that's why we needed you to have Metamask. Of course, if you weren't here for the first part, it's not a big deal. We will mainly be deploying through JavaScript VM, but I'll take you through what it looks like to deploy through injected Web3. And Web3 provider, don't worry about that for now. Cool. So then we see account. So because we're on the JavaScript VM, it gives us a couple default accounts. So you guys all have your own accounts with your own hex addresses that look like OX88 and stuff like that. But we're just on this local network, and so as a result, we have all these different accounts that we can use to mess around with. Gas limit we will not touch at all. Value we will touch once today, so we'll explain that later. And then once we deploy a contract, we'll see it down here. Cool. So why don't we go ahead and get into some coding. Okay, so as we said, we always want to start with the SPDX license identifier. So that will be the very first line of any Solidity code we write. And then we're going to do Pragma Solidity, and now we need to define what version we want to use. So defining what version, I could do, like 0.8, 0.12, but that's not great because I can only use that. Another option is you can use this up arrow followed by 0.8.0, and that is going to let you use any, so like a major release version is like 0.8 point anything. If you do this, this will allow you to use like any compile version. Again, if you look down here, this drop down, up here, we can compile using any of this, like 0.8.4 or whatever. What I usually do is I actually give it a range. So I do less than or equal to, rather greater than or equal to 0.5.0 and less than 0.9.0, which hasn't been released yet. So that's usually what I do, and that's majority how I write most of my Solidity files. So that lets you know exactly what we should be using to compile. Can everyone see back there? Looks clear? Okay, great. So now let's go ahead and actually make our first contract. So what I thought of was maybe we could just simulate having a contract represent a property. So there exist crypto games where you can buy land. I'm not really big fans of them, but I just thought that this could be a practical use case of it, like buying virtual land or whatever. So let's say anytime anyone wants to show that they own land, they could make a call or basically create a contract that represents that property, right? So this may remind you of very basic like Java examples where it's like, oh, let's write a class for pizza or something like that. So if we're doing contract property, the very first thing we want is state level variables, right? So when I think about a property, I think, okay, well, we probably want to know what price the property is listed at. And we also might want to know what the location is. So string public location. And then in addition, because we probably want to know who owns it, right? If we don't know who owns it, it's kind of useless. So we'll do address, which is actually a type in and of itself, which is this Ethereum addresses are 160 bits long, so that'll be our address, and then address public owner. So actually, this in and of itself is actually a functioning contract. If you notice, if I go down here, it's pretty much already been compiled, and I could deploy if I wanted to. So actually, you know what? Why don't we go ahead and just try deploying on JavaScript again. So if we deploy, we'll look down here, and if we see down here, we see a green check mark. We can try to maybe expand this a bit so we see it more. And this tells us that it's actually been deployed on our virtual VM at this address, which is on our local blockchain. Like this is not actually anywhere. So I guess, is everyone deployed? Good to go? Great. So the cool thing is without even having any getter functions, if I open this, this contract down here, you can see, everyone can see their contract down here. You can actually take a look at what the values for location, owner, and price are without even having a getter. So if I click this button, it'll show me the price. So we already talked about uint. Price is going to be what? What's the default value for uint? 0, that's right. So we see 0. Can anyone guess what the default address for a string would be?
Empty string.
Empty string, that's right. So we just say empty string. And what about for an address? What do you guys think the default address should be if I don't declare anything? Right now we haven't assigned any value. What should the default be?
Something with a 0x.
That's true. It's just going to be 0x and then a bunch of zeros. That's just our default address. So that just so happens to be how Solidity handles when you don't give it a value. And now let's go ahead and actually write some functions. So if we remember, actually maybe I should make this full screen. If we remember, every time we write a function, we always need to start with actually let's go back to constructor. Let's start with writing a constructor. So anytime anyone makes a call to this contract, we want to call this constructor, and we could explicitly set the values to these defaults, or probably when someone creates a property, they're probably going to give us the price and the location and stuff like that, right? Like that's intuitive, right? Like someone wants to create a property, they're probably going to enter what the price and the location is. So what we'll do is into the constructor, we will pass in some price that they will give to us, and also some string. Now, if I write string location, I'm going to end up with an error. and it's going to tell me that the location must be storage or memory. And the reason why that exists is because function arguments, anything outside these state variables, these are local variables. And local variables, we need to know where to store them. So if we do memory, which is almost always what you want to do, that is not going to cost you any gas. If you use storage, that could. So we're going to put in string memory. And that's sort of what I was talking about when it comes to passing. Have we heard by passing by reference versus passing by value? Does that sound familiar to people? Pretty much like, for example, if I pass like a list to something else, quite frequently in most languages, that will be passed by reference, which means if I try to set another variable equal to that list, then do some funky stuff with it, it will affect the original list. If I pass by value, nothing happens, right? Like if I give you an integer, and then I set like, let's say I say x equals 5 and y equal to x, right? If I set y to something else, that's not going to change the original x value, and that's because integers get passed by value. The same thing happens in Solidity with strings, lists, we'll get to dictionaries and hash maps, but these are all passed by reference, which means anytime something is passed by reference, we need to explicitly state whether it's memory or storage. So that's why we have this memory keyword. Does that make sense? Great. Oh, yeah.
So how come it knows to do it for a string but not for a unit?
So for a uint, it is passed by value, so it's just automatically going to be measured, pretty much. It is the easiest way to think about that. Cool, so on the constructor, I guess intuitively, right, this looks pretty familiar. We just want to set the state variable price to the thing we're passing in. We also want to set location to location. Now, the interesting thing is we didn't pass in owner to our constructor. And the reason we don't have to is because in any Solidity contract, and this is pretty cool, there is this object called MSG, message. And this message is pretty much the object that's automatically generated by whoever is calling this contract, right? Or if it's a function, then it's a different message. So within the constructor, if I look at this object MSG, that is going to correspond to all the data of whoever and however this person called this contract. And the cool thing is on message, there's a property called sender. And if I do msg.sender, that allows me to access who called this constructor function, aka who initialized this contract. And that's going to be the owner, right? So I can just do this. And great. Now we have a constructor that effectively takes all these different things. So if I were to try to deploy this again, if we notice down here, beforehand when we first tried to deploy it, if I temporarily command X this, notice that like on deploy, there's no sidebar, right? It's just deploy. But if I add this constructor, all of a sudden, now there's this like, gray stuff like, okay, uint256 price, string location. That's because if I want to call this contract, I now need to pass in the initial values, right? So price and location. So let's say I'm just going to do price 100, and let's say location is like, I don't know, 1200 Fake Avenue or something. You can do whatever you want. Okay, if I do this and I click deploy, we're going to get another contract down here. So this is our first contract. Let's just delete our first contract. So this guy we no longer need, it's now outdated. And now we go down to this. Now one important point to notice is we edited the code, redeployed, and it made a different contract, right? Which is kind of weird. But it's actually why smart contracts are so powerful. Because once a smart contract is deployed, it can never be changed. Like you cannot change the source code. You can only use the functions that existed in that smart contract to change stuff around. So that's why smart contracts are so great. Because if someone writes code and you see the code and you're like, okay, this is the smart contract. I know that this can never be changed. So I can have trust that whoever wrote this cannot then go later on and change the stuff and screw me over somehow. So it's just an important point to know. So this is our new contract. We've deployed, and if I take a look at location, it's now 1200 Fake Avenue. If I look at price, it's 100. And if I notice, I selected this account, which is this account being selected here. Remember, we have a bunch of accounts. Because this was selected when I hit deploy, that was the address that deployed this contract. So if I look at the owner, it should match this OX5v3 guy, and it does. OX5v3, yada yada. Does everyone follow so far? I'll take a quick break for any questions. Any questions? Yeah.
Do we find this like somewhere later on? Like.
Yeah, it's pretty interesting. So what happens is all this source code gets sort of chunked down into byte code. Remember, like when we write this file, it gets passed into compiler, okay. Then we get byte code and it's stored on the blockchain. So on the blockchain, all you really get to see is the byte code. So this stuff is actually usually not visible. Like the source code won't be visible to anyone who wants to see it on the blockchain.
Gotcha.
Although the stuff processed through the compiler will be.
Okay.
But yeah, that makes sense.
Does it mean like email it down?
Oh wait, did you mean like, will I email this after? Oh,
Yeah.
well now, yeah, I'll email it after.
Okay, that's great.
Sorry. Yeah.
Could you give us an example? Could you give us an example of when we want to use storage instead of memory for a reference?
Yeah, sure. A good example is, it's a weird way of how stuff works, but if you make a mapping, so a mapping is a hash map, the funny thing is you put a hash map within a hash map, you have to use storage. I don't know, it's like kind of like a weird stringent requirement, but I think it's more like sometimes I get forced to use storage because I have to, just by the restraints of Solidity. But usually there's almost like no case where I actually want to use it, most of the time. Cool, yeah? Explain memory a little bit more. I guess the easiest way to think about it is, without getting too low level, the memory is just explicitly used within the function itself. And so because it's used in the function, the blockchain doesn't actually need to store the state of it all the time. So if I just need this, like for example, right, when someone calls 1200 fake avenue, right, into this string memory location, all the contract needs is just that initial whatever. It handles it, but it doesn't need to store that underscore location at all on the permanent blockchain at any point in time. So that's pretty much the idea of memory. Cool. Any other questions? These are good questions. Oh, what's up? Oh, do you guys want lights on?
Yes.
Okay. Oh. Oh, God. Oh, it's all over.
Maybe just that one layer.
Maybe just the one light. Sorry, guys. Wait, is there one back there? Or it might also. Okay. Oh, was it just for visibility? Lights on. Okay. All right. I will just continue from now. Okay. Cool. So now let's go ahead and write a couple of. So right now we have a static contract, right? We initialize some stuff. Let me check time. Okay. So we have a very static contract. It doesn't really do much. People can create their own contract to represent the property, but we can't actually do much with it. So let's go ahead and write some setters, right? Let's say later on we want to set the price. So someone wants to go along and change the price. Obviously I pass in UN price. This is going to be public. I'm just going to set price equal to underscore price. And I probably want to do the same thing for set location, right? So I'll pass in again string memory, underscore location, make it public, and new location equals underscore location. So if I do this, I could redeploy and get a new contract that works well. Let me, it's cutting off a bit. There we go. Can you see it? Okay. So one important thing is, does anyone see any potential issues with how we have this contract currently set up? So someone went along, they created this contract, right? So boom, nice, we created it. Now anybody, maybe the person who didn't create it, can call set price and set location, right? Which probably isn't good, because what if you have this great $500,000 house and someone comes along and is it's actually worth $20,000 and now I'll buy it, right? It's probably not good. So what we want to do is we want to find out how to actually restrict who can call these functions. So to do that, we're going to use something called the require statement. So require is pretty much assert, and it takes up to 2 arguments. So the first is going to be some Boolean, and then the second is going to be an error message if the Boolean is false. So in this case, we're going to do message. So we're going to require that the message.sender equals the owner. Okay, so first let's think about, and you can also call it with just one. You don't need the error message. But let's think why this works. So this message object is going to be local. For example, the message in the constructor is different than the message in the function. This is a very important conceptual point. So whoever calls the set price function, right, when the set price function gets called, that message object has different information than when the constructor was called. Does that make sense? These two messages are different, which means this message.sender is the person who originally called the constructor. This message.sender is whoever's now calling set price. Does that difference make sense? Okay. So I need to make sure that whoever's calling set price is indeed the owner. And if he's not, I could add some error message. And I would probably, then do the same thing for set location, right? I do another require statement. The problem is what happens if I have maybe price, location, number of neighbors. I might have a bunch of variables, and I don't want to have to write require, whatever for every single one. That's very tedious. That's not really efficient. So the way to solve this is we use something called a modifier. And this will probably be one of the last new concepts we talk about today. So a modifier is cool because it looks just like a function. You have modify only owner, we'll declare it as public. Oh my bad, actually I don't think we do anything on modifier. I think modifier is great. So modifiers just look like this, we just have the name. And inside the modifier, what we'll do is we'll have a bunch of require statements. So in this case, message.sender equals owner. And so all of a sudden you see it's quite intuitive, right? This modifier, only owner, it's going to require that this message.sender equals the owner. And what I can do now is I can just go ahead and add only owner at the very end of each of these things. And it adds it as a modifier tag on top of each of these things. So pretty much what it does is it just puts this require statement pretty much at the front of it. And let's go ahead and add like maybe a useful little blurb like cannot call this function, let's see, only owner can call this function, or something like that. Or maybe let's say you are not the owner. Okay, but there's one other thing. We actually need to put an underscore at the very end of each modifier. And intuitively how to think about this is this represents like the body of the function of whatever you're applying it to. So it's kind of like, you know, if I tag this with only owner, then what this looks like is it's like require this guy and then the rest of the body. And that's sort of represented by the underscore. Just some syntax. So now we have a pretty nice contract which has this like only owner clause, we have the set price, we have set location, everything's looking pretty good. And now let's go ahead and attempt to deploy this. Let's go ahead and do this on the testnet. So we can actually say that we've deployed a real functional smart contract on the testnet. Or like on an actual blockchain that people use. Cool. So we look at this, everything's looking great. I hop down here, and when I'm figuring out what to deploy, instead of doing JavaScript VM, 1 second, get out of this. Okay, so instead of doing this, I'm going to go to injected web3. Now, make sure that when you do injected web3, this thing right here should say Rinkeby network, okay? And the reason why it knows I'm on Rinkeby is because it's connected to my Metamask, which is currently on Rinkeby. Okay, so everyone have this toggled as injected web3? Working for everybody? Cool. So now what we're going to do is we're just going to go down here, and again, we'll just put some price and location. So it could be this 100, and then in quotes, 1200 Fake Avenue, or whatever you want to call it. Oh, no, not last place. Okay, and then we'll click deploy. So if I click deploy, it's going to open Metamask, right? So instead of just deploying locally, it's actually deploying via Metamask, which is my actual account. So you should see this screen. Does everyone see this? Can I get some thumbs up if you guys see this? Great. Okay, now I will just confirm. Before we click confirm, if you want to look, it's just this thing called gas fee. We usually need to pay. If we were on the mainnet, this would actually be real money. Luckily, because Eileen has already taken you through how to actually get test ether on the Rinkeby network, you already have the necessary ether on this test network to actually deploy. So click confirm. And it will take a little bit of time right here. If we wanted to view on Etherscan, we could open this up, go look at what it looks like. Still pending. Okay, boom. And now we get this green check mark telling us we've deployed appropriately. Does everyone have the green check mark? Congrats, you've actually deployed your very first smart contract on a test network, on a real blockchain, not just your local whatever. So hypothetically, let's say you deployed and you wanted to see his deployment, you could actually go find it on Etherscan, provided you knew his address and whatnot. So there we go. I guess we have some time. Oh, actually, okay. There was more stuff on this that I wanted to get through. We can do it next time, just to actually flush this out into a real contract. That would be really cool. But it only takes about 25 more lines, and you would have the entire backend for a pretty much a property trading platform. So if anyone wanted to create a property and then have a certain price and location, if someone wanted to buy it from them, you could actually, in 20 more lines, pretty much create the entirety of the backend for that app. You would build the front end, and now you have a completely functional property trading app, which is pretty cool, I think. You would need to take a lot more time to actually do this if you were to do this in Web 2. So I think this is one of the powers of Solidity, is you can get a lot done because you already have the blockchain serving as your backend. So really, this is maybe like CS2 level code that you could be writing and actually build really, really cool apps in addition to a front end. I guess I'll go back to the slides. There's some other stuff I wanted to look at. One more last thing. Okay, so that's what we just wrote, and we will send the slides out later. Okay, this I do want to talk about. So we didn't get to the part of like actually transferring ether value, which was going to be a good segue into this. But just when we think about security, I do want to introduce this code. So this is actually a real life example of something that happened in 2018. So in 2018, there was a token. So you guys all have this like Avery token, right? So that's an example of an ERC20 token. And in 2018, there were a lot of other ERC20 tokens going on, except we're on the testnet, they were actually on the mainnet, all right? So this is code from an ERC20 token called BEC. And in April 2018, there was a problem in this bit of code that led the entire token to pretty much be defunct because someone could give themselves a bunch of it. And then a bunch of exchanges shut down ERC20 token trading for several days, caused a big dip in the ERC20 market, all from just a quick bug, or not really a bug, but an exploit that you could find in this area. So I guess if you guys all want to look, we can walk through line by line, and then if you guys want, you can take a guess at what you think the issue might be. I guarantee you guys have heard about this issue before. It's not some very obscure situation, but I think it's pretty cool because you can just look these 12 lines of code led an entire market to crash. So it's really important that we think about security when we're developing Solidity stuff. So let's look at the first line. So does this all look like not foreign to people? Like this looks kind of like normal code a bit that we could see in like Python or Java or something like that.
Just make that
Okay, so function, we have the name, batch transfer, don't worry about that. Address, like these 2 colons, it's pretty much just an array. Just think about it as like a list in Python. So address, receivers, we have some value, and then don't worry about this public when no pause stuff. So the value is pretty much the amount that we want to give to each of these receivers. So some wallet is going to have some amount of money, and let's say like, I have a wallet, I want to call batch transfer because I want to give maybe Eugene and Alice each 10 of my BEC token, right? So this sounds like perfectly normal. I look at this count, so that's line 15. So this is like actual code from, like I didn't write this, this is actual code. So uint and then the CNT receivers.length, so this is the number of people. I'm going to take the amount, which is the number of people times the value, because if I want to give 10 BEC to both Eugene and Alice, the amount is going to be 20 that I need. Some require checks to make sure that count is above 0. We're not trying to distribute more than 20 people, which is probably just an efficiency thing. I'm going to require that the value I'm giving is greater than 0. Balances, just think about it as a hash map where the key is going to be each address, and the value is actually how much balance you have, right? Has everyone seen that syntax in Python or something of the sort? Great. So I need to make sure I have at least the amount I want to give out. So I need to have at least 20 BEC. I'm going to .sub just subtracts it. So I'm going to subtract the amount from my balance, and then I'm just going to distribute it to each of my receivers. And don't worry about, and then the transfer function on line 23 is how I'm actually transferring stuff in this value. So I will give you a hint and tell you that the issue is not, you don't need to worry about this last couple like for loop lines that look kind of confusing. The issue arises within the first 4 lines of code. So I guess if anyone wants to take a guess at what it might be.
Is it that it never checks if the receivers are the same as the one that's trying to do the transfer?
It is not. Even if the receiver was the same, it would just, like if I were trying to send 10 to myself, it would just subtract 10 and then add 10. So it wouldn't be too bad. But good guess. Anything else? Oh, well, I will show you because I think we'll probably wrap up at 6:02. So last slide, or I guess second to last slide. That's the error. So it's kind of weird why that's the error because it looks super normal. But really what happened is imagine that the underscore value that I'm sending. So remember, amount is going to be a uint256. Have you guys heard of an overflow error before? It's an overflow error. So what happens is, let's say I'm going to put my value at maybe, let's say uint256, largest value you can have is 2 to the 256 minus 1, right? So maybe I'm going to send underscore value like half of that and then send it to 2 receivers, right? Or maybe half of that plus 1 and send it to 2 receivers. The point is, if you compute count times the underscore value, you could theoretically get a number that's out of bounds, past the uint256 amount, and then it's going to loop back around, right? So if you guys have ever done like Java, like overflow integer error goes back to like negative 2,100 something or the other, or 2,100,000, whatever. This for uint it would start back at 0. So I could theoretically get amount to be 0 if I carefully constructed what the value I pass in is plus the number of receivers. So what I could do is I could pass in a value, a really, really large value, and the amount is 0. And let's see what happens. I require, it passes both require statements because the amount is 0. So balances of message.sender greater than or equal to 0, like that's obvious. And then I just subtract amount from my balance, which is 0, and all of a sudden I'm just adding underscore value, right? So all of a sudden tokens are created out of thin air. Does that error make sense to everybody? Cool. Now this was actually fixed. So luckily this is no longer an issue. Because this was compiled using Solidity maybe 0.5.0. Since then, there's actually safe checks now when you multiply stuff, which is really great, so you don't need to worry about this. So if you compile this in Solidity 0.8.0, it would work perfectly fine, and you would have no issues. But back in the day, Solidity was not that smart, and as a result, an entire market crashed because one line of code was messed up. Make sense? Cool. So that is all. You've deployed stuff. You've learned how to write some stuff. Oh. Signing QR code if you're interested in coming to the next one. It helps us figure out how much boba we want to order. I guess one other thing just worth noting is we were considering using the ERC20 token that we all gave you, this Up Avery. In addition to boba, we might offer some like random food items, and maybe with Up Avery you can buy it, so you get Up Avery every time you go to every single time. It would just be like a fun way to use Up Avery, so it's not totally
That's a good idea.
But we will always have free boba, so no worries. It's just that if you guys want to have food or something of the like, You can set it up Avery, I'll set up a smart contract so you guys don't Facebook message me, you can actually go like use blockchain stuff to figure it out. I'll set it up, give more info at the next meeting. But thank you for coming, everybody. I appreciate it. Hope you learned stuff, and we will do more next time. Thank you. Yeah. Oh yeah. So actually.